Functional groups. This we're not going to dive too deep into. If you go into something like kinesiology or physical therapy, you'll do a lot more, zooming in on the functional groups, and it becomes really kind of fascinating and interesting to think about how people move, because it's not quite as simple as we present it in this class. And we present it in this class this way strictly for time. If you knew all these muscles, and I know it's a slog, once you know them all, then you can do fun and interesting things with thinking about how people move. Or if they can't move, how do you tell what's wrong if they can't, say, lift their arm in a certain way? In your lab book, the actions that are listed are all what we call a prime mover and agonist that's producing, the major force of a particular muscle. But there's other things a muscle could do that are very, very important. So for instance, antagonist is the opposite, or it will slow down a particular movement. So I'll give you some examples of this in class because I think it's easier when you can actually see somebody doing it. But you want to slow down the opposite movement. So for instance, say you are doing push-ups and you're going to start out and your toes are on the ground here. Here's your toes. There's your body. Let's say that's your butt. There's your head, and you have 2 arms down, all the way down on the ground. And that's where we're starting. Now, notice that this is a strange looking person. Little context. I'm just going to add a floor here. Okay. You're starting and your elbows are extended or fully extended. And then you're going to want to lower yourself to the ground. And when you lower yourself, you're going to have to bend here. You're going to have to flex at the elbow joint in order to get yourself down. So I'm going to draw another little person. See if I can. Okay, the elbows are going to have to be flexed in order to get down. Now, flexion is done by biceps brachii or brachialis could do that, but you don't need to do that. Lower yourself to the ground. Gravity will do it for you. As soon as you start to just flex a little bit at the elbow joint, gravity will do the rest for you. But what you don't want is to slam your face into the ground like that. So actually what you're doing at the same time as you lower is you're actually contracting the opposite muscle, the triceps. Now triceps normally would just extend at the elbow joint. But instead what you're doing is resisting flexion. You're using your triceps to resist the opposite. You do this all the time. Otherwise, you would get hurt quite frequently. So if you abduct at the shoulder joint, so let's say you're standing here and your arm's sticking straight out and you abduct. If you do not abduct, say your deltoid here while lowering, you're going to just lower very quickly. That one's not going to hurt as much, but you could imagine your arm's just going to fall, slam into your torso. If you lower it slowly with control, you are adducting as you're doing this, ADD, but you are going to keep contracting an abductor. And it's going to contract antagonistically. So hopefully you remember from chapter 10, there's different types of contraction and they match up really nicely with this. So for instance, concentric, hopefully you remember, is shortening. So shortening would be like if you extended at the elbow forcefully, the triceps is doing it, and that's shortening. Right, okay. Now, to do the opposite, eccentrically, you would contract while lengthening. And you can feel this. And the example I gave you of the shoulder joint, abduct first. So your arm is sticking out like this. And then slowly adduct. Slowly. Add slowly. Then what you'll notice is that if you can just put your other hand here on your deltoid, you'll feel your deltoid contracting while lengthening. Oh, I forgot to put that important word. Contract while lengthening. So, antagonistic muscles are very, very important to slow down movement so you don't really hurt yourself while doing things like, well, this one might not hurt you, but push-ups would. If you let go quickly, you're going to slam your face into the ground. That's bad. Synergists. Synergists are any two muscles that do the same thing. They work together to produce and often we're talking about concentric, they'll shorten together. You could think of any two muscles in your lab book that do the same thing. Those are synergists, two or more. In many cases, when you look at two muscles that do the same action, they could probably do it alone as well. But there are a couple interesting movements that you can't do unless you have a synergist working together. And I'll give you two really good examples. Because yes, you may be asked for an example in the exam. That is the worst hand ever. Okay. And then whatever, that's the forearm. Okay. So hopefully you remember that the forearm has anterior compartment, flexors, and then posterior compartment extensors. So extensors like wrist and fingers, flexors vice versa. So how do you then, this would be AB because thumb is lateral. How do you AB duct? How do you AD duct for that matter? Either one of them, because you get flexors and extensors. How is that going to work? You have to have a synergy. For example, let's say we'll go with AD. AD, adduction. What do you use? Well, you're going to use a couple muscles working together. Flexor, carpi, ulnaris is a good choice. What's the other one going to be? Extensor, carpi, ulnaris. That's moving to the ulnar side. And then vice versa for abduction or radial deviation. Change these ulnarises to radialises and it'll work. But note, you've got to have that synergy because if you just contract flexor, you're going to flex. If you just contract extensor, you're going to extend. You have to do them together in order to adduct. This now is a foot. You hopefully know, here in the anterior compartment, you're going to have dorsiflexors. And in the posterior, plantar flexors to stand on your toes. On the lateral side here, there's the fibularis muscles. They're going to be the ones that evert. Fibularis, longus, and brevis. Easy enough. Who inverts? Well, this is an example of a synergy that you absolutely have to have the synergy in order for it to work. And I'll give you a great example because it's easy to remember. In order to invert, you have to spell the word correctly. Sorry. In order to invert, you would need tibialis anterior plus tibialis posterior. Both of them together. The two tibialises working together in synergy will invert at the ankle. So if one of them operated alone, like just tibialis anterior, you'd dorsiflex. Just tibialis posterior, you'd plantar flex.